Nested conditionals can be difficult to work with. The more levels of nesting, the harder your brain needs to work to keep everything in mind at once. But thankfully, there are lots of safe conditional manipulations that you can do using the tools you probably got in your editor or IDE. In this video, I'm going to show you some of what's possible and explain when to use a guard clause. Hi, I'm Emily Bache. I'm a software developer and creator of Salman Coaching. Welcome to my channel. Okay, so I'm scrolling through some code here and it's got a deep nesting code smell. There's a load of complex conditional logic, which is often the kind of thing you see in legacy code. Because once a conditional like this becomes too complex for you to hold everything in your head at once, people get afraid to change it. And when they need to make changes, they tend to just kind of add more if conditions and only the cases they particularly need to fix. And I've seen methods with thousands of lines of code like this. I mean, what's on the screen is actually the Gilded Rose Carter, which I have another video about and I show a full worked solution. There's a particular refactoring, lift up conditional, that works really well on this one. But today I want to show you some different safe refactorings that you can use with complex conditional logic. I'm going to be using Java with IntelliJ, but there are definitely other tools that do the same thing. In particular, I want to show you where a guard clause might improve matters and when to use that. I've created this project specifically to help me to practice manipulating conditionals safely. So I've got a class here full of static functions and a bunch of test cases that cover them. And they come in pairs, these functions. So this one is called invert negative and this one is called invert positive. And they contain exactly the same if statement, the same conditional expression, but in different forms. And the practice that I'm going to do is to convert one to the other form. So the name of the function tells you the conversion you're supposed to do. This one I'm going to invert and it turns into the other one. And this one I can then also invert to turn back into the previous one. And I've set the tests to run automatically when I change the code, just as a safety net, although I'm trying to learn to use my tools better here. So actually none of these refactorings should cause the test to fail, but it's always good to have that backstop there. So that was the first one, inverting an if statement with the tool, and usually the positive is easier to read, so you'd prefer to have that one. The next pair of functions here is about redundant else. This else here is actually redundant. I could make it look like this one, and my tool can remove that for me. And I think that makes it a little bit easier to read. Of course, I might actually prefer to have those else statements. And at the moment, I couldn't find a way to get the tool to add them again. So I'm not sure if there's something I'm missing here, but I'm resorting to just writing else at these places and then reformatting the code to make it look right. But I think that it's actually not harder to read. So either of these two forms, but not the one they started with just a random else in the middle. The next pair of functions are about De Morgan's law. And I don't know if you remember De Morgan's law, but it basically says that you can replace an and with an or. So the tool can do that for me. And if I replace that and with an or, this looks simpler. But sometimes, you prefer to have it the other way around, so you can convert it back again as well. Both of these do exactly the same thing. It's just a question of readability and preference. The next pair of functions are about splitting and joining and statements. So in this version, you've got separate if statements, and in this one, you've got both of the conditions in the same if statement. So I'd like to join these together, and for this, you have to get the cursor in the right place, the first if statement, and then it'll let you merge them. So now it looks like the second one. This one, I'd like to split, so I put the cursor on the and then it will split it to look like the previous one. But I've got a bunch of redundant else's here, so let's just remove these redundant else's. And now I've actually got a redundant return statement here. I didn't quite work out if I could get the tool to remove that for me, so I'll just take it away by hand and rely on my tests. But that was obviously an okay change. The next pair are doing something similar, only with or statements. Here I've got two if statements in a row with the same body. So I could join those ones together but I have to get the cursor in the right place. Merge sequential if statements. And then it starts to look like this one, which I'm going to show how to split in a minute. But I need to get this condition in as well. It doesn't offer me that directly, but if I first expand it to an if-else, and then, no, that's not what I wanted. Here I want to merge it again. There we go. And then I get it back in with the others. And this one I was going to show you that I can split that. So that's just put the cursor onto the actual or that you want to split, and it will create those additional if statements for you. The next pair is another kind of join. In this case, I've got two if statements with the same condition. And in this version of it, I've got that condition consolidated just into one if statement. So again, I can convert between these. So let me see. I want to join these ones together, and it's offering to do that for me. Merge them. Just gives me a bit of extra white space. But otherwise, that seemed to work. This one, I want to split into two if conditions, and I didn't find a way to get the tool to do that for me. So the way, there's different ways to do this, but if I just copy that if statement there, close this and paste the same if condition, that achieves the same effect. So there I would like to have tests actually, just to check I didn't make a copy-paste error. The next three examples I've got here are all about guard clauses. Now, a guard clause is a way to basically handle the exceptional case first, quickly, leaving the rest of the body of the method to deal with the normal case. So I've got three different scenarios for this. The first, when the function is actually void, and it's also got this really good format where the guard clause makes a lot of sense, where it's just an if body with no else. And you can convert it to this. This is the guard clause, guarding against the case when x is not equal to 3, we need to do something else. Well, nothing, basically. So the easy way to introduce this guard clause is just to invert the if statement, and you can get rid of the guard clause the same way. Except my tool has given me a redundant else, and I don't need that additional return there. So the difference between these two, with the guard clause handling the simple case first, the main body of the whole function is basically got one less level of indentation compared with this one, which normally makes it easier to read and a bit less complexity to worry about. So you've kind of handled this exceptional case first, and you're dealing with the normal case. Now, this is a void function that had the ideal form for this refactoring. I wanted to show the next example here where there is actually a return value. So I've got multiple returns in this function, and this is the guard format of the same thing. So again, it's very easy to convert one or the other, just inverting the if statement and removing the redundant else. But I think you'll agree that the format here with the guard clause is easier to read because there's less indentation for the main body of the method. Now, the third example I've got here, this is where I've got, again, it's not a void method, it's got a return type, but I've got some kind of variable that's going to be the result that I'm returning only once at the end. So I've got a single return here. And you can invert this if statement, and then it suddenly has multiple returns, and it's got, this is my guard clause. A guard clause basically presupposes that it's okay to have more than one return. This is the way of writing the same thing with this condition first, but without the early return. And you don't get the benefit. This code is still indented. Some people have a corporate standard that says that they're not allowed to have more than one return statement per function, and then they can't use guard clauses. But in my opinion, this is actually a good use of an early return. There are, of course, better ways to handle this kind of problem as well with more object-oriented techniques, but I think I would prefer to see this than this. Your mileage may vary. Okay, so those were all on my sample practice application. I've got one that's a little bit more complicated here to try out my newly practiced skills on. This is the Payroll refactoring kata, and I've got a conditional statement here to do with calculating a paycheck for my employees. So I'm looking at this and thinking, well, okay, I could use some of my safe refactorings on this. I do have some tests in case I make any mistakes. Now, the first thing I'm looking, that's the negative form there. So the first thing I'm just going to invert that. Surely that's going to be easier to read. And then I've got an else if next to each other. I could merge that to an else if. That looks better. And then this is now looking a much easier to read function with two kind of special cases and then the normal case. I've still got this single return thing. I could move that to a multiple return, and actually the tool can do that for me. It's offering to move the return closer to the computation of the value, and it puts in multiple returns for me, which I quite like. But again, if your policies don't allow it, then you can't do this. But it leaves this as a redundant else, and then suddenly the main body of the logic is no longer indented, and I like that. But this is clearly also a code paragraph, which I could extract. It's a code paragraph, it starts with a little comment that explains what it does. I could extract this as a method, compute amount. So let's just see if I extract that. Now, it's not returning an amount now, it's returning a paycheck. I think I took a little bit too much. The code paragraph to calculate the amount is just this bit. Yeah, and I'll just name that calculate amount. And then I don't need this comment, and I can inline this variable. And I'm starting to like this code a lot more than it was when I started, and all my tests are passing. So you can think of this as basically a guard clause. Oh, there's another redundant else there. There we are. Two guard clauses, then the main logic extracted and returning the normal result here. So I don't know if you agree with me whether this code is improved, but I think it's easier to read than the code I started with. I encourage you to use this kind of conditional refactoring exercise just to practice with your tools and your programming language and see if you can get more fluent with these kinds of moves. You can get the code that I've been using from my GitHub. There's a link in the show notes. And I'd like to thank Nicholas Carlo for inventing the payroll exercise that I showed, and then Gregor Riegler for the Java translation. I lead a community of technical coaches called the Saman Society, where you can get more resources like this. So do take a look at our website, samancoaching.org, and consider signing up for our newsletter or joining one of our online events. In the meantime, I wish you all the best working with complex conditional logic in your production code. Perhaps look for places where introducing a guard clause would be a good first step. Happy coding!